Hello, everyone, and welcome to our webinar, Migrate to Azure PostgreSQL. Hello, everyone. Good morning, and welcome to our webinar, Migrate to Azure PostgreSQL. Today, we'll be covering why Azure PostgreSQL, the migration tools, assessment and migration plan, migration process, and modernize with Azure PostgreSQL, and a few case studies. But before we get started, let's do a quick introductions.
Hey everyone, I guess I'll go first. Andrew Ruffin here. I'm part of the AMD. We basically provide quite a bit of the technology that you're likely already using on Azure, or if you're not using it, I'm here to help you understand why for PostgreSQL. I've been in the semiconductor world for 8+ years and worked in technology policy before that, so it's been a fun ride.
Hey everyone, Mike Shelton. I'm with Microsoft. I've been with Microsoft for 23 years, all focused in the data space and data and AI. And I'll be taking us through the discussion on why Postgres, or why Azure for Postgres.
Hello everyone. I'm Venugopal. I'm Technical Director at Quadrant, leading our migration tool development. It is QMigrator. It is a revolutionary migration tool. It is able to perform migrations, database migrations, data migrations, as well as report migrations and ETL migrations. You will have some insight into it in today's webinar.
All right. So this is Stuti. I'm Partner Alliance Manager with Quadrant. I have over 12+ years of experience in driving partnerships and customer success. Well, I'm here to cover why Quadrant. So let's get started. With over 15+ years of industry experience and presence across 10+ countries, we deliver value to our customers. We are Microsoft solution partner in data and AI, digital and app innovation, and infrastructure, where we help our customers migrate, modernize, and drive innovation with all our industry and technical solutions across Azure. We are headquartered in Redmond, Washington, with nearshore locations in Canada, Mexico City, Brazil, and we have some presence in Europe with 4 delivery centers in India, Warangal, Hyderabad, Bengaluru, and Chennai. And we have some presence in APAC as well. If you have locations, we can help you drive value across global regions. Our Azure expertise includes migrations, digital and app innovation, AI design, also Microsoft Fabric, Microsoft Purview, and infra modernization. And coming to our Data Migration Center of Excellence, we provide services like assessments, database migrations, database AI enablement. We also do a lot of webinars and workshops like these to train people, to help with hackathons, boot camps. We have database certified professionals. Our popular migration paths include Oracle to PostgreSQL, SQL Server to PostgreSQL, DB2 to PostgreSQL, Oracle to Fabric migrations, that's a new one, and PostgreSQL to Fabric as well. We are an infrastructure and data and AI partner with Microsoft with specializations in infra and DB migrations, data warehouse migrations, analytics, and infra and DB migrations on Azure. And we have some cool marketplace offerings, so we'll share the deck after this. webinar, please feel free to click on those and check it out on Azure Marketplace and Azure Portal. Thank you. Over to you, Mike.
So I just wanted to spend a few minutes and talk about why Azure Database for PostgreSQL. So to get started, I want to talk a little bit about the increasing popularity of Postgres. As highlighted by the Stack Overflow developer survey that you see here, Postgres has many key features that attract developers, and extensions can enhance Postgres' functionality. Postgres also offers AI capabilities like pgvector for performing approximate nearest neighbor searches on high dimensional vectors, which is essential for tasks such as embedding-based search, image and document similarity, and chat memory retrieval. By providing a unified platform for storing structured data, unstructured text, and embeddings, PostgreSQL eliminates the need for vector databases and complex data pipelines. Postgres also has a large active community that contributes to its rapid development and robust documentation. So next, I want to talk a little bit about Azure Database for Postgres itself. So Azure Database for Postgres is a fully managed database service provided by Microsoft Azure that runs the open source Postgres relational database engine. For the enterprise, it is designed to simplify the deployment, management, and scaling of Postgres databases in the cloud. Some key capabilities of Azure Database for Postgres is that it's a managed platform as a service offering with automated patching, backups, and maintenance. It has built-in high availability and several deployment and scaling options. And security is certainly a key aspect of the deployment of Azure Database for PostgreSQL. Now, from the developer's point of view, Azure Database for Postgres has full compatibility with open source Postgres. It has support for popular extensions. It has a flexible development environment with a choice of development models, customizable maintenance windows, configuration parameters, and local development with easy migration to Azure. It works seamlessly with GitHub Actions, Azure DevOps, and other CI/CD tools. It has integration with other Azure services like Azure Functions, Logic Apps, and AI tools. It has cost-effective burst compute tiers for dev test environments and start-stop capability and flexible server to save costs. Now, next, I'd like to get into a little bit more of the enterprise capabilities that Postgres has within Azure. And to get started, I want to talk a little bit about some of the security elements. First, Azure Database for Postgres Flexible Server supports Microsoft Entra ID authentication, enabling centralized identity and access management. Private endpoints in Azure Database for Postgres provide a secure and private connection to your database from within your Azure virtual network instead of accessing the database over the public internet. And Azure Database for Postgres offers comprehensive data encryption capabilities to help protect data at rest and in transit. All data that is stored in Azure Database for Postgres is encrypted at rest and managed by Microsoft. But for more control, you can use Azure Key Vault to manage your own encryption keys. And this is supported in the flexible server deployment model. Now, Microsoft Defender for Cloud as an add-in provides advanced threat protection for Azure Database for Postgres, helping you detect and respond to potential threats and misconfigurations, detect unusual harmful database activities, including SQL injection attempts, access from unusual locations, brute force logins, send alerts and recommendations with several security to the Azure Security Center, and provide remediation steps. You can perform vulnerability assessments by scanning your Postgres configuration and usage patterns to identify weak authentication settings, excessive permissions, and outdated Postgres versions. Now, data protection monitoring for sensitive data exposure and data exfiltration attempts as well. Now, Defender for Postgres integrates with the Microsoft Defender for Cloud, giving you a centralized security dashboard and security score to track your database security posture. You can create automated workflows using Logic Apps or Sentinel for incident response. Now, from a high availability perspective, availability zones in Azure are physical, separate locations within the Azure region. Each zone is made up of one or more data centers equipped with independent power, cooling, and networking. The purpose of an availability zone is to provide high availability and fault tolerance by isolating resources from data center level failures. This enables you to build resilient applications with zone redundant architectures. And with Azure Postgres Flexible Server, you can deploy a primary and standby server in different availability zones within the same region. And this setup ensures if one zone fails, the standby in the other zone can take over. You can co-locate your database with other zonal resources for your application to ensure you have high availability both for the application and for Azure Database for Postgres. Now, Azure Database for Postgres Flexible Server provides backups in an automated and managed way with a retention period from 1 to 35 days with a default of 7 days, and can be stored in geo-redundant storage, allowing for point-in-time restore. Also, Azure Database for Postgres read replicas are a feature that allows you to scale out read-heavy workloads by creating read-only copies of your primary SQL database. And these replicas stay in sync with the primary replica using asynchronous replication. Now, talking about Microsoft's capabilities and its contributions to Postgres 17, Microsoft has become a significant contributor to the Postgres open source ecosystem, both through direct contributions to Postgres core and by building innovative tools and services on top of that. And beyond just the core investments, Microsoft has done work in a variety of other areas by building on top of Postgres, as well as within the community. So as an example, POSET is a free virtual conference dedicated to Postgres. It's organized by Microsoft and the Postgres community. It features talks from Postgres core contributors, Azure engineers, extension developers, and application architects. The most recent virtual conference was this past June 10th through the 12th, which included 42 talks over 4 live streams. So it's a great opportunity to increase your knowledge and see what the community's talking about related to Postgres. Now, next, I want to talk a little bit about the global reach of Azure and how Postgres fits into that. Azure's global infrastructure enables low latency access to applications and data. This helps address data residency, compliance for regulated industries, and disaster recovery and geo-redundancy. And moving on, talking about some of the industry capabilities for building AI applications. Specifically, data is the foundation for generative AI applications, and Azure Database for Postgres has many capabilities to support generative AI applications. The first thing I want to talk about is this native vectors and vector support. Now, a vector refers to a mathematical structure, essentially an array of numbers, and embedding refers to the process of mapping data into that vector space. So a vector embedding is a numerical representation of your data, like text, images, audio, and it's transformed into this dense vector, like in the high dimensional space. And the goal is to capture the semantic meaning or contextual relationships of that original data. And using the PG vector extension, you can store vector embeddings in Azure Database for Postgres. And then vector similarity measures how alike 2 items are, and it's calculated using metrics like Euclidean distance or cosine similarity. Now, vector similarity is used in applications such as recommendation systems, text classification, image recognition, and clustering. Now, vector indexes are specialized data structures used to accelerate similarity search in this vector space, and especially useful in AI applications. 2 common vectors that are available to you are IVF flat and HNSW. But Azure Database for Postgres has another vector index called disk-ANN. And it's available through the PG disk-ANN extension and was developed by Microsoft Research using an approximate nearest neighbor algorithm. Now, when you look at Azure AI Integrated, there's a couple of things I want to just mention briefly. The first is the Azure AI extension, which allows you to integrate with Azure AI services such as Azure OpenAI and Azure Machine Learning directly from within PostgreSQL queries. You can simplify your generative AI application development and support things like real-time scoring with ML models, sentiment analysis, summarization, and other LLM services directly from within inside the database. And one other piece is GraphRag. GraphRag is an advanced RAG technique developed by Microsoft Research, and it improves contextual understanding of LLMs by integrating structured knowledge graphs into the retrieval process. This is especially useful in domains like legal research, where relationship entities are critical. Now, Azure Database for Postgres now supports GraphRag capabilities through a solution accelerator and the Apache Age extension. By combining graph-based reasoning with retrieval augmented generation to enhance quality of responses beneficial for your AI applications. And last, I talk about Copilot powered. And here I want to just mention the Postgres extension for Visual Studio Code operates both local and cloud-hosted Postgres databases. And this is a tool intended to simplify the development management of Postgres databases. And you can use it to browse and explore database objects like tables, views, and functions. And you can run queries with IntelliSense support. And you can visualize schemas directly in VS Code. And it integrates with GitHub Copilot, so you can use natural language querying easily to work with your database in Azure Database for Postgres. So with that, I'd like to pass it on as I finish talking about the capabilities for Azure Database Postgres, and we'll continue on with the rest of the content.
On the AMD team, I wanted to give, and Mike, thanks for that handoff, great information about all the great work that Azure is doing around Postgres to make the software product the best it can be. I'll talk a bit about the hardware and infrastructure options and why you'd want to land on AMD on Azure for Postgres. And I'll give a little bit of extra context as well. So thanks, Mike. Let's go to that first one there. I'll kind of give a brief introduction for AMD on Azure, and then I'll dive into some performance details that might help you out when you're making your decisions. So a quick, we launched EPYC, which is our data center processor on Azure. It was the first cloud provider to have EPYC in the cloud back in 2019. And since then, we've launched 4 generations of EPYC and a diverse array of products and services, from the VMs that you choose and with the infrastructure as a service to the software and platform as a service options you know and love. You're probably already using AMD infrastructure on Azure. You might not even know it. Or if you're considering Azure for the first time, I'll talk about why you want to consider AMD. So with that background, let's talk about the infrastructure specifically. I live and breathe this alphabet soup of VM names on Azure. So a bit of a hack for you, look for the little A in the VM name to know whether AMD EPYC processors are there. There's some exceptions from back in the past. LSV2, our first VM back in 2019, H-series VMs, which have been AMD only since basically HBV2 in 2019. Those are the basic exceptions. But for the most part, you're going to see that little A after the main VM name. So let's go forward. Yeah, so this is the alphabet soup. I won't go through all the details here, but I want to say we've got over 40 different VM types on Azure. A lot of these VMs are used by internal services or third-party services. You might not even know it, but generally speaking, I've categorized them into the overall areas you might want to consider. So for general purpose, I'll dive into the details of general purpose performance because that's most relevant to this audience here with PostgreSQL in particular. We'll talk about D, E, and F. So I won't start there. I'll save that for the next. Basically, where you see my face, there's a couple of confidential computing options, which are some of the Azure's been a really big leader in offering confidential computing where you can protect data in use. We've got this AMD Infinity Guard technology that basically allows you to protect the data in use. So for highly regulated or data protection needs for sensitive data, look at those confidential VMs. We've got some V6s that are in preview now, so go check those out. HPC, it's H-series VMs, high performance computing. We are scaling up to many thousands of cores with advanced networking. The most advanced processors in the cloud are on Azure. Frankly, they're arguably the leader, I would say, in HPC in the cloud. And these VMs have been around and have been all AMD since 2019, with more on the way. HPV5 just got announced a bit ago. And We offer some storage options, of course, which is also potentially of use for database workloads where you need a lot of local storage. The V4, LAO, and LAS V4 VMs just went general available like 10 days ago. So very hot off the presses. They're offering the most amount of storage per vCPU on Azure. And then we offer a number of visualization offerings. Most recently, our NVADS V710 with a Radeon Pro V710 GPU. Great fit as a workstation in the cloud, high performance CPU and GPU. And last but of course not least, near and dear to everyone's minds right now is all things AI and accelerated options. On Azure, they have the MI300X V5 VM, which is our AMD Instinct GPU, the first one we've done for AI inference and training focus. We've been doing GPUs in the cloud or in supercomputers for many, many, many years. The top supercomputers in the world use Instinct GPUs, and Azure has them as well for you all to go check out. Let's go to the next one. I want to dive into the details. As I mentioned, the V6 VMs, these are our the most common D and E. And we just launched the first F series, compute optimized. So general purpose, compute optimized, and memory optimized. Those three, I think, are going to be the most of interest to PostgreSQL users. Today, if you go look at PostgreSQL, Azure database for PostgreSQL flexible server, you can pick the V5s. We should see V6 in the future. And if you're just going to launch your own VM, V6 is where I would highly recommend you start. We've been putting a lot of work into testing and benchmarking on Postgres. E-Series in particular, I think, is of interest. I talked to the product managers at Build just a month ago at this point. And I said, hey, we think a lot of users are most interested in E. So I wanted to make sure you see what we're offering with the E-Series in particular on the right. Before I go there, though, just quick updates on the actual VM themselves. They range from 2 to 96 vCPUs. The F series goes up to 64, and you get multi-threading off, so you get the full physical core. And they're announced by Azure as the fastest x86 CPU performance in Azure. So a really interesting option if you want to get the most performance. And then a variety of memory to vCPU options. Summarizing on the right, we're comparing our V5 VM, which is based on our 3rd gen EPYC, and our V6 Azure VMs, which is based on 4th gen EPYC. If all the numbers are confusing, just look for the highest number basically and start there. The V6 VMs are where we think you want to start. And basically you see on the right that gen over gen, we're getting basically 20% more performance per dollar or 27% better performance. And so if you're looking for simply the less costly option, look for V5. But if you want to get the most out of your dollar and invest the savings in your margin or other areas, then I would definitely start with V6. Looks like there's a couple questions. I'll kind of try to get to them as I go, multitasking here a little bit. But I wanted to give a little bit more context as well around just general purpose. If you're using Postgres, you're almost certainly using Linux for most of your IT estate. And Azure has been majority Linux users for quite some time now. You don't necessarily think of Azure for Linux, but certainly, yeah. I mean, as Mike talked about, there's amazing amounts of work being done on the open source ecosystem with Azure, and AMD is part of that. So just at AMD, whenever a new VM gets released, we test a large array of benchmarks we think are most relevant for the community, always taking some input. For Linux, we look at MySQL, Java, we look at Nginx, Redis, and FFmpeg. And of course, I'll talk about Postgres as well. But we looking at the summary of all those, we do multiple VM sizes as well. And these data are the result of that. So based on US East pricing, every region is a little bit different, but we use that as a standard. We see an average across these 5 workloads up to 22% improved performance per dollar for our latest V6s, and up to 58% better per dollar for our compute optimized VMs. There's no really comparable compute optimized VM in this generation, so we just compare the same memory to core to give you that as apples to apples comparison as possible. And then looking at the E series compared to the non-AMD option, we're seeing up to 26% better per dollar over the prior gen. So when it comes to general purpose x86 performance on Azure, certainly look to AMD as the option. So let's go next here. So wanted to do a quick, MySQL, I know there might be some tension between the Postgres and MySQL teams. I think they're both great options. SQL Server is a great option too. got plenty of information on that too. But just looking at another open source database option with MySQL, you're seeing quite a bit of uplift. We're looking at same gen and gen over gen AMD compared to the non-AMD option. And we're talking up to 28% better performance per dollar. Given that some of the, if you look just straight up at pricing, the AMD option is typically the less costly option, and it's more performant. So it's a great option for you. So let's go to Postgres. Last but not least, of course, as Mike said, the most popular database with developers for that Stack Overflow survey, it keeps getting better and better year over year. Azure's doing great work contributing to Postgres. Met a few of the Postgres maintainers that are at work at Azure. A lot of really interesting work going on, as you can see, as you heard from Mike. AMD also contributes to this open source ecosystem and, of course, builds the hardware to bring that performance to life, which you can see here. So we've tested the latest gen VM 16 and 8 vCPU options based on some feedback from the Postgres Azure product managers. And they said, hey, test 8 and 16. We see a lot of customers interested in those VM sizes. So looking at these, you see up to 15% better in performance for Postgres, and up to 27% better perf per dollar. So again, just take those savings and add them to your margin if you're building your business with Postgres in the background. Go on give yourself a bonus maybe if you're saving money for the company, whatever works for you. Or if you have a spending agreement with Azure, for example, then take and invest those in other areas like Azure OpenAI services. Work with Quadrant to find the best use for those dollars. So I want to make sure that you're aware of all the great options you have on Azure. Provide a variety of choice. So I want to make sure you're fully informed on that front. And then last but not least, I'll share some resources. We built 2 migration guides, MySQL and Postgres. We built these together with Quadrant Technologies with Azure to provide these migration guides from on-prem to Azure, whether you're using IaaS or the SaaS PaaS services on Azure. And then if you want to go really into the details, you can look at our tuning guide that AMD put together for getting the most out of all of your AMD Epic infrastructure on Azure. So I'll pause for a second there if you want to take a little quick picture of the QR codes. And if you have any questions on those or need information, always feel free to reach out to me. I'll get to questions later, but I want to pass it over to Vanu next.
Thank you, Andrew. Thank you for giving the inside details of how AMD is powering Azure PostgreSQL and Linux VMs. Especially, we use a lot of Linux VMs for the migrations. QMigrator uses them for doing the migrations. Right, and you heard from Mike why Azure PostgreSQL, like how it is making, how it has a lot of features and how it is making difference. So I'll be covering the migration challenges and how we are doing the migrations. So especially when we are trying to migrate PostgreSQL from other databases like Oracle, SQL Server, or any other legacy platforms like DB2, right? There could be some challenges like data type differences, the actual code, like procedures, functions, and then once we convert all that, then performance optimization of it, and then there is a workload, the applications that are using the databases that needs to have the data access layer changed, and then we had to do the actual data migration in sync, like we need to bring the data data replication as well, like the CDC. We had to do the cutover with no data loss. And then before we do the migrations, there is a lot of testing and validations we have to perform. So for doing all this, definitely some migration tools and techniques are needed, and I will be covering that. So part of the migration tools, like Azure Migrate, is a centralized hub. It helps in assessing the migration workloads, and it does have it itself does server migrations, like any infrastructure that we need to migrate, part of the migrations. And DMA tool helps migrating the databases, SQL Server, MySQL, and Postgres, also MongoDB, from their on-prem or other clouds into Azure. And it also has a component, Azure App Service Migration component, which helps in migrating the applications. And there is an Azure Data Box feature, which is for large-scale migrations where large volumes of data is there. That can be copied in the on-prem and then transferred to Azure so that it can be handled efficiently. And Azure DMS, you can see here a little bit more details, like it supports migrations from on-prem Postgres and other VMs, like any VMs, and as well as like from different clouds. Migrates in both modes, like offline mode and online mode. Offline being like you copy the data and when database is not used, like there are no transactions are happening. Online being like applications are using with minimal cutover time. You are migrating the data, including the transactions and doing the cutover. So a QMigrator is our proprietary tool that does the migrations at a scale. It supports all these databases like DB2, SQL Server, MySQL, Oracle, and even including NoSQL and PostgreSQL available in on-prem or in other clouds. All right, they all come in they all can be migrated into Postgres, which is not only just migrating the data, but also converting the code and doing all the testing that is needed before we do the cutover. So here you can see it has all the aspects, different modules, client onboarding to doing the actual assessment, doing the migrations. Part of the migrations, we do the schema conversions, data migrations, and any of that validations, doing functional validations, performance validations, deploying to different environments right before we go to production, and then doing the production cutover as well. And as part of the process, it provides the dashboards and reports so that we know exactly where we are. So with this accelerator, it reduces the time from months to weeks, and in turn, it reduces the cost of the migration. So I'll go a little bit more in detail of the migration planning and process. So the migration process covers discovery and assessment. We need to like scan the environments, like the databases, the servers, and doing the actual code scan. And for databases like where Oracle, where AWR reports are available, we can do those. We need to do the scanning of that so that we know the important information of the how much capacity being used, and actually knowing the architecture, migration complexity, all this part of the assessment process. QMigrator helps on providing this discovery tools and processing the information that we gather. And we have to do the environment setups, connectivity, repository setups, part of the configuration, and then part of the migration is doing the schema conversion, schema migration, like data migration, and setting up a high availability disaster recovery and doing production cutover. But before we do the production cutover, like we do have to do a lot of testing, like testing in the development environment, SIT, doing load testing, and finally do before going into production UAT also. We have to perform, and QMigrator helps in all these aspects. Okay, we'll go a little bit detail in how QMigrator is helping. It is AI-enabled feature, how it is helping in assessments. So we onboard the clients through our SaaS application, SaaS portal, myqmigrator.ai. So once the client onboarding is done, we provide some discovery tools for doing the infrastructure scan, database scan, and any report scan. All right. So that happens in the client environment, and then it produces the reports. And we also conduct sessions with the clients and gather the information. They might have some documents, or as we have the conversation, we collect the through transcripts, we collect the information. So all those are the information that is collected from the discovery tools, and as well as from the meetings. Those things are uploaded into the SaaS portal, and it analyzes that it creates an assessment document. And then it also identifies the gaps, like what information it is collected and what more it has to collect. And then it gives the opportunity for the users to, means it asks the questions to collect that information, and then it collects, and finally it creates a assessment summary report where it gives the migration plan and what is the TCO and what are the challenges. It covers all those aspects. It's really very cool. And part of the migration process, as I was covering before, like we need to create the environments. The environments being development, and then there could be a reference environment, like whatever the source database. That is also having a dedicated reference environment is important. And then there are other testing environments like SIT, UAT, or any staging environment, and then prod as we get close to moving to prod. And the part of the database preparation, which we had first convert the schemas, the storage objects we call it as, convert the schema and deploy it, do the data migration and do the data validation. And then we do have like code objects like procedures, functions, triggers. Those things have to be converted and make sure that they are getting deployed and there are no execution issues. And other things like how the security is set up, like users and roles, any other jobs or replication processes have set up. All those have to be converted or has to be taken care in the target environment. And we need to have some test cycles created to do the find whether any execution issues and any functional issues, and then performance wise, like different test cycles needs to be created. And along with not only just database preparation, we also need to think about, keep in mind about the workload, like application changes, data access layer changes, and keep that also ready for the testing. So part of the testing, right? So it's better to have a good clarity before we start, like the migration, the total application, how the test cycles we want to prepare, like break it down by application modules or some workflows, right? Have that clarity, and then execute SIT, like as the development progresses, execute SIT cycles. And any bugs are there, address them in the subsequent, like in the development, and then put them in the subsequent SIT cycles. And at almost once you have about 3/4 of SIT done, then you start your load testing as well. We should cover all the critical test cases and like how as we put the load on the application, how it behaves. I mean, so you can start with a small, like a single user, and then increase to like 10%, 50%, and then finally reach to 100% load. So have this perform this load test cycles, and then keep it ready for UAT before you do the cutover. So here, a typical how we do the production cutover. Like here, you can also see our QMigrator architecture, how it is actually deployed in a Kubernetes platform, Kubernetes cluster. Where it creates tasks as we perform things. It creates this conversion tasks, migration tasks, and the validation tasks, and then it further, for each of this granular level tasks, it further creates, and then they all run in parallel, and that's how we achieve the scale. I'll have a little bit more information on how fast we do the migration later, but that's how the QMigrator works, like getting the data and code from the source database to loading into Postgres. So initially, we, as part of the production cutover, we do the initial load and then change data capture so that we are capturing all the transactions that are happening on the source databases. And then we have to do the validations, make sure, like if needed, before if there is a mock production cutover, then part of that we can create additional validation DBs and then perform the validation there. And then when we are ready, right, we have to make the application read-only, the application that we are switching over to. For the Postgres, make it as a read for a period of time, so that we are seeing all the data, that is the transactions that are happening on the current applications are shown in the target environment. And then when we are ready, we do the switch over to use Postgres for read write, and other database like either Oracle or DB2 as like only just data is going back. This is just a reverse CDC, just in case we having a fallback plan. And when it is we are completely good with how the application is working, we can turn off the old database. That is our cutover process. And here also you see we do have an autonomous job agent that is actually the core behind the how fast we can do the migrations. This job agent creates the it reads the source databases and creates the jobs, like initial jobs and the CDC jobs, and then using this ETL, it runs those jobs, a lot of jobs in parallel, and achieves the scale. Right. A lot of demos are there how we do this in our website qmigrator.ai. I'll go through some of the case studies that we have recently, the migrations that we have recently performed at a very high scale. Like recently we did the migration of a healthcare client. They have legacy systems, applications in the .NET and Oracle databases, and they do have significant amount of Oracle code in there, and the legacy .NET application is also haven't been upgraded for a while. So it is we took that, we converted the database from Oracle to Postgres, also remediated the application to work with Postgres, and completely moved into Azure PostgreSQL. When the client had the challenge in terms of scalability and like moving into new regions, but after moving to Azure, then it is very easy to increase the scale and also to spin up to start to have a new region. So that problem is solved moving into cloud. Next use case. Similarly, e-commerce for an e-commerce client, we just use the QMigrator tool to do the data migrations. Almost they have taken up to migrate like at a petabyte scale. So on average, they migrate one database, which is of a size about 20 terabytes. One database a week. Once it goes through about a month period of time for doing some testings and all that. But on average, one database is migrated into production a week. So with QMigrator. So here you can see some stats like in terms of a database which has a lot of code, like it has 4,500 plus tables, and it does have partitions, and if you look at the packages, there are 200 plus packages, 11,000 plus procedures, and 1,000 plus functions. So it is very code intensive. Some of the code is even having 5,000 lines of code. But using our tool, which we are improving over the years, we are able to migrate a significant amount of code. And now it is even better with we added AI component to it, and we are like 95% plus we can convert automatically all the code. And similarly, if you look at the right side, the data volume that we migrate is about 10 terabytes per day. That is significantly, very significant. And even the transactions, we handle about 1 GB per minute. That kind of translates to about a terabyte of transactions we migrate. or push it into the target database. So that is the scale we are working. And I also want to, like, we are not stopping there once the databases are migrated into Postgres, right? You have heard from Mike, right? Azure PostgreSQL and Azure PostgreSQL especially is loaded with a ton of AI features. So we are helping clients to even modernize their applications, their workloads, especially using with the PostgreSQL. So I'll walk through a use case, what we have done. This is our internal application. I told earlier before, like we are doing an AI-based assessment. So this AI-based assessment, I mean, when we do the assessment, it used to take about a month at least, having this back and forth and collecting all information, processing and all that. We are able to reduce that to a week with this AI-based tool. It is now goes at the client pace because our intervention is very less with it. Because we provide the discovery tools and we provide ability to upload the reports, and then as we have these conversations or any documents they have about the migration, all can be uploaded, and then it processes all that. So that is the one. It is giving a little bit more detail. Like we do the data ingestion with whatever the information we are collecting, we are loading that into Postgres database, and then a lot of this information is again which generates the embeddings, those vectors, and then we store it in the vector table along with the actual data. So both are information and the actual vectors both are stored side by side, and this data is compared with what's supposed to be the part of the assessment, like what is the information that we are supposed to collect, and that gap analysis is being done, and then it identifies what information we collected and what information we are yet to be collected, and it again requests that information. Right, agents work behind the scenes, and those agents will again come up with what is those gaps, and it will again set up some more sessions with the clients to collect that information. So that is a pretty cool application, and like behind the scenes, the technologies that we are using, like a RAG plus the semantic ranker to do the better search of the information or getting the better results, improved results. And in some situations, we are using graph RAG, as Mike also mentioned, right? When information is having relations, and it is better to use those relations and get the information accurately, right? So that's where graph RAG is also being used. We see that between all these techniques, right, the relevant information that we are getting is improving, and that information is passed to the Azure AI, which is like LLM, and it takes that information and gives the actual information back. So all these are done behind the scenes with agentic actions that you can see here. So this is the one we like. If you see the workflow, like we usually how we help the clients setting up their AI environment is environment setup, database setup, and whatever the extensions they need to have along with it, and then how they need to do the data ingestions, how like embedding generation, storing the embeddings, how to create vector indexes, how to process the queries that are coming from their users, how do we do the search, and getting the information, passing that information to the LLMs and getting it back, and how to deploy the agents. We help on all these things. I think that's pretty much I want to cover. Thank you. I'll hand over back to Stuti.
Well, thank you, Wayne, for covering, migration challenges, the tools, and also, how we can modernize with Azure PostgreSQL. If we can have the slide back, we are offering a free assessment for all PostgreSQL and MySQL workloads. If you're looking for an assessment, we can do this as complimentary for the people who have joined this webinar. So it's a great offer, and we can help you, migrate seamlessly. Well, if we can have rest of our panel on board, we'll take a few questions now. All right. So let's see. I see a lot of brilliant questions here. So I think, Mike, I think we have a question from Van. How does PostgreSQL on Azure support multi-region compliance policies? Would you want to answer that?
Yeah, definitely. And I put a comment in the chat as well, but essentially you can deploy Azure Database for Postgres into the region that you require, that you need. So you can choose the location or the region in which you would like it to be running and have your data stored.
Right. Another one from Tori. Can AI simulate failover scenarios for PostgreSQL to validate resiliency?
Yeah, so I'm not familiar with there's anything built in that would leverage AI to simulate failover or those sorts of things. You certainly could configure and test it, but to have AI simulate that, not that I'm familiar with.
Yeah, I want to add on to it, like our migration tool, we are having one of the module is how to test the HA and DR. I mean, every client wants to, after migrations, wants to test their environments for it. So we kind of providing that feature in the tool.
All right. So another question from Marvin, what risk mitigation frameworks do you offer if a migration project fails or stalls midway? Venu, would you want to answer that?
Yeah, I mean, that's where migration, I mean, we have to plan such a way, I mean, there is what components in it. Like if it is a code conversion component, definitely a lot of test cycles are needed. And how it is, how we are improving it, right? But if there is no code component, like then the mock cutovers, doing the actual how the production cutover happens, that has to, like 1 or 2 times we have to simulate and test it. So that planning is important, right? To ensure that, and most of the time, like we've been, as we come close, right, we get the confidence, and it has to go forward plan only, right? The most of that's where the success comes. It's not like for any, like as part of the cutover, if you're seeing some issues and all, it is able to address, like performance issues is one of the thing, like mainly data validity and performance issues, but they can be solvable. Like we work with many clients addressing those issues and moving forward. That is much better option than falling back at that point. Like that is at during the cutover time, but during the whole process of your migration, like over the months, then you need to continuously evaluate where you are and if it is working the way you want it.
Great, thank you, Venu. So another question, how do you track and report ROI from migration projects beyond infrastructure cost reduction? I think there are a lot of questions that audience has posted on the ROI, like what are the realistic ROI timelines? Mythixa has posted for post-migration for a mid-sized enterprise. So would any of you want to answer the ROI-based questions here?
So if it is infrastructure and licensing cost is a measurable, ROI, but the intangible one is modernization. Like being on Postgres, like anybody is helping themselves to be able to have all these extensions that are out there and continuously being added. Right, in terms of AI, but even in not also AI, like Postgres is continuously expanding. And that gives a lot of value for modernizing your applications.
Great. Another question from Akhilesh. If I have to implement an on-prem system to store text embeddings on Postgres and implement RAG chatbot, is that possible?
Store text and implement RAG chatbot. Yeah, you can do that. It's because Postgres itself, on-prem Postgres itself has that extension. But being in Azure, like you ultimately you cannot use that alone. For creating the embeddings or using those embeddings, you need to have a OpenAI or any LLM that you need to use. And Azure PostgreSQL has that inbuilt, part of the Azure PostgreSQL, so you do not have to use another service. It is part of it. That is the advantage. But it is certainly we should be able to do it.
Right. Another question from Christian, I think, Mike, for you. Can PostgreSQL serve as backend for generative AI applications?
Yeah, definitely. We mentioned a few things earlier, and I know that we put some comments in the chat as well. Definitely, with the PG extension, you can store and search, do your vector similarity search on your vector embedding. So definitely support that aspect. And then it could be a source of data for your RAG applications. The vector similarity search provides that capability. The DiskANN provides great indexing for performance and scale that you would have with inside of Postgres. And then with, as we were just mentioning, the Azure AI extension and some of the other capabilities, you can actually initiate the creation of the vector embeddings from within inside of the database. So it makes the development process very easy. And there's several solution accelerators. We talked earlier about the Graph RAG, which aids in generative AI applications. There's also other accelerators for semantic re-ranking and other types of aspects that are critical for Gen AI applications. So definitely great backend for generative AI applications.
Right. I think there's one more question that we can take from, I think we answered this one for on-prem RAG bots, but there's another question. How does Quadrant manage schema differences when migrating from Oracle or MySQL to PostgreSQL? So Venu, if you want to take that.
Yeah, that's the beauty of this tool, QMigrator, right? We are we will see from going from one platform to another platform, there will be data types or other things, differences are there, all of them. And also especially code, if the code is written, that code has to be converted into a Postgres format. So we've been doing this for a while, about 5 years now. So we like over the years we improved how we convert. But then lately, what happened is in the last 3 months, we are able to incorporate AI solution to it. Whatever there could be in each migration, there could be some feature, some syntax that we probably are not able to handle it. Now we have a module which we can pass that to AI and get that converted. We know that we cannot use AI for the total conversion because a lot of hallucination and it might not. But these special scenarios where it automatically converts and then somebody manually we can validate and get that. So the cycle has improved, the conversion rate improves with that, and then the cycles are faster in terms of conversion and migration. So there should not be any hesitancy to migrate from other platforms into Postgres with this so much advancements that are happening.
That's awesome. Thanks, Venu. And I think we can take one last question. There's a question from Pat. What's the impact of IOPS tuning on PostgreSQL performance in Azure? So Mike or Andrew, if you want to take that question.
Mike, I think you're muted.
Thank you, Andrew. Yes, I was. Yeah, I'll comment, and then Andrew, if you want to add to it
Sure.
from your perspective. But with Azure Database for Postgres, you can scale storage size and IOPS independently. So then you can, if you need more IOPS to increase performance for your application characteristic, you can one, measure, and then two, size accordingly to meet your needs, and then you pay for what you're using and really allow you to optimize your performance to scale and ROI from that perspective.
Yeah, I think Mike covered it really well. The storage performance has been greatly improving gen to gen on Azure, so you've got a lot of different options you can take. I think I mentioned the L series VMs that just came out have a ton of local NVMe storage with, I think, millions of IOPS if you need that kind of storage performance. So you have that at the top end, or as Mike said, you can scale as you see appropriate. I think the tools that Quadrant offers should help you to understand what is your storage requirement and what would be the best fit on Azure. So lots of good help you can get from the tools.
Right. I think that calls for an end of this webinar. Well, thank you, Andrew, Mike, and Venu for sharing all that knowledge and how customers can modernize and migrate to Azure seamlessly with AMD. So, everyone who has attended this webinar has the access to the free assessment. Please log in, and if you want to have a meeting with the panel as well, you can actually scan that and put in a special request. We can work on that too. Well, thank you so much and see you again.
Thank you.
Thank you all.